Chapter 6, Section 1, Part 2. We're going to answer that alligator question from yesterday. The equation for the first alligator, if you remember, was 4 plus 1.5x, and alligator number 2 was 6 plus 1x. Now we're going to use those and graph them to find out exactly when they will be the same weight. So our first alligator, we'll say is the red alligator. We're going to put a dot at 4 since that's where we start, and we go up 1.5 over 1, which means up 3 over 2. Okay. The second one, start at 6 and go up 1 over 1. Which means right here, at 4 months and 10, they will both be 10 pounds. 4 months, 10 pounds. That's the solution to this system, which tells us exactly when the alligators will be the same weight. Now, could you use a table to solve this? You totally could, just like we did with the puppies way back at the beginning of part 1. Okay, next. Part 2, they're going to ask us or give us some more vocab words. A consistent system has at least one solution. That means it could have more than one. Independent means it has only one. Dependent has infinitely many, meaning our two lines are exactly the same line. And inconsistent has no solutions, which means those lines are parallel, so they're not ever going to cross. Okay, what is the solution of each of these systems? We're going to try graphing them again. The only thing different today is that this one is not yet graphable. So we have to get it in a way that we can graph it. We want to get it in slope-intercept form. So what I need to do is get that y by itself. So I'm going to add the x. 2y is equal to x plus 2. Divide everything by 2. So I have y is equal to 1/2 x plus 1. Okay, when I go to graph that, I'm going to start it at 1, and I'm going to go up 1 over 2. And then down 1 and back 2 just to get the rest of that line. Okay, the second line, this one, I'm going to start at 1. Oh, go up 1 over 2. Okay, so this one is exactly the same line. If it's exactly the same line, notice that it touches on every single point. So if we go back to our vocab, infinitely many solutions. That one touches on every point. So this is a dependent line that has infinitely many solutions. What is the solution? Infinitely many solutions. There is not just one. Okay, does the solution of each system in part A and B use, what is the solution? Use a graph, describe the number of solutions. Okay, part A, or letter A here, we're going to start at -3 and go down 1 over 1, since it's a negative slope. Okay, oops, sorry about that little mark there. The second one starts at 5 and also goes down 1 over 1. Okay, if you notice, these two are not getting any closer to each other because they have the same slope, which means these are parallel lines. If they are parallel lines, that means it is inconsistent and will have no solutions, which makes sense since they didn't touch. So this is a no solution. Okay, part B, we have to get this y by itself. If I divide everything by 3, we'll see that y is equal to 3x minus 3. Okay, you can probably see already that this equation is the same as this equation, so they're going to be the exact same line, which gives us a dependent system with infinitely many solutions. So we're just going to write infinitely many. Okay, last thing that we're going to talk about before we're done. Before graphing the equations, how can you determine whether a system of equations has exactly one, infinitely many, or no solutions? Okay, well, we just discovered that they have no solution if they have the same slope. Okay, because that makes them parallel, which means that they will never touch. Infinitely many solutions is when they're the exact same line. Okay, so exact same equation. One solution is when they are not the same. So they're two separate lines that have to cross somewhere. All right, that's the end of chapter 6, section 1. Lots of vocab, but you should be able to complete the full assignment, which is on page 363. Numbers 10 through 18 evens, 19 through 21, 22 through 30 evens, which is the new stuff for part 2, and finish off that lesson quiz.